Hey, this is Mr. Molo for lesson 3-2, linear functions. So a big part of today's lesson is going to be determining whether something is linear, so a straight line, or non-linear, pretty much a not straight line. You can always graph them to tell, but there's other ways to do it faster. So if all else fails and you have a calculator there, you can always just graph what they give you and you can see if it's linear or not. But I'm going to teach you some tricks to kind of how to see if they're there faster. So here, just something about perimeter and area. One of them is linear, one of them is not. So we're going to put in 1 for the x's here. And in order to find perimeter, we need both sides here. So if I put in 1 for the x, let's just come up with our equation. So I have 1x plus 2x is 3x, plus 1x is 4x, plus another x is 6x. And so I'm going to put in x to figure out my perimeter here. So if x is 1, 6 times 1 is 6. If x is 2, 2 times 6 is 12. If x is 3, 3 times 6 is 18. If x is 4, 4 times 6 is 24. And if x is 5, 6 times 5 is 30. Okay, here, now we're going to multiply them. So we have 2 times x, which gives us 2x squared. Okay, and remember these equations. So one was 6x, and now this one we'll do in red is 2x squared. So remember these equations here. One of them is linear, one of them is not. So if I put in a 1 for x squared, 1 squared is 1, and 1 times 2 is 2. If I put in a 2 for x squared, 2 squared is 4, 4 times 2 is 8. If I put in a 3 for x squared, 3 squared is 9. 3 times 2 is 18. I'm sorry, 9 times 2 is 18. 4 for x, so 4 squared is 16. 16 times 2 is 32. And if I put in a 5, 5x squared, so 5 squared is 25. 25 times 2 is 50. All right, so now let's graph these and look at the difference here. So I have 1 and 6 would be about right there. 2 and 12 would be about right there. 3 and 18 would be there. 4 and 24 would be there. And 5 and 30, there we go. Finally, a nice one would be there. Okay, so all else fails, we can graph it, and we can tell this is pretty good for a straight line. Good job, Mr. Molo, putting those dots in there. Okay, so pretty much a straight line there. So if we find perimeter of something, it is linear. Okay, notice how our equation is just y equals 6x. We'll talk about that more later. But look at the table. So if something is linear, it means it needs to have a constant pattern. So our x's are constant, 1, 2, 3, 4, 5. And our y's are also constant, from 6 to 12, from 12 to 18, 18 to 24, 24 to 30. They're all going up by 6. So if you have a table, you can tell if something's linear if it has a constant pattern. If it's a graph, then you can tell it's linear if it's a straight line. All right, now let's look at the area. So I have 1 and 2. 2 and 8, 3 and 18, 4 and 32, and 5 and 50. Okay, as we can tell here now, this is not going to be a straight line. It's going to have that curve, so this is non-linear. And we can also tell again by the table. So we go from 2 to 8, okay, so up 6. Oh, but then we go from 8 to 18, so that's up 10. And then we go from 18 to 34, that's up 14. And then we go from to 32. And then 32 to 80 is up 18. So there's not really a pattern there. And you can kind of tell that this is going to be nonlinear because it's not a straight line on the graph. Okay? So kind of like last time, it'll ask you in 3 different ways if something is linear or nonlinear. Okay? So it'll ask you in a table. So in and output table, we did that last time. A mapping diagram, again, we did that last time, and a graph. The graph is easiest to see if something is linear because it's a straight line. And then the other thing on this section is discrete and continuous, which we also talked about a little bit last time. So discrete is if it has these individual dots, versus continuous means it's the whole thing. So remember, my example of discrete and continuous was last time with age, or with people, I'm sorry. You're either 1 person or 2 people or 3 people or 4 people. You're not 3.27 people. That's not possible. So that would be something that's discrete. Continuous is something like money. You can have, $2.37 or something like that. So that would be an example of something that is continuous. All right, so if we look here at this page, again, 1 and 2 are probably going to be the easier ones to see. Pretty much just asking if it's a straight line. 1, that's not a straight line. That is non-linear. Does not go in a straight line, so we just need to write non-linear. Okay, number 2, that looks like a pretty good straight line to me. So that one is linear. So that one's good. All right, 3 and 4. So now we have a table. So here, we're going to see if there's a constant adding or subtracting pattern for both x's and y's. Okay, so x's here, 1, 2, 3, 4. It looks like we're adding 1 each time. And then for the y's, it looks like -1 to 2, 2 to 5, and 5 to 8. It looks like we're adding 3 each time. So this would be a linear equation. If you ended up graphing that, you would get a straight line, but kind of the cheat way to figure it out is if there's a constant adding or subtracting pattern for both the x's and the y's. All right, let's look over here. X is -1 to 0 to 1 to 2. That one looks good. We're adding 1 each time. And then from 0 to -1 to 0 to 3, that is not good. It looks like we subtracted 1 and then added 1 and then added 3. That's not a constant pattern there. So that one's going to be non-linear then because it's not going up by the same thing every time. So 3 is linear. It's going up by a constant amount every time. And 4 is non-linear. All right, 5 and 6. It's a lot easier to tell you what makes something linear or makes something non-linear than linear. So these are the things. If it has any one of these things, it is non-linear. Okay, there's 5 of them. So if it has x times y, it is non-linear. If it has the square root of x, it is non-linear. If it has the absolute value of x, it is non-linear. If it has y divided by x, it is non-linear. And then the last one, probably the most common one, is if it has an exponent. So I'm going to write an x squared there, but know that any exponent works. Okay, so any of these weird things, if they are in an equation, that's going to make it non-linear. So if I look at number 5, 3 minus 2x, looks good to me. Doesn't have an x times y, doesn't have an absolute value, doesn't have a square root, doesn't have an exponent. So we're good on number 5. This is a linear equation. Okay, number 6, on the other hand, has this exponent right here, has x to the 3rd power. So that's going to be non-linear because of that. If you ended up graphing that, you would see that it is not a straight line. It is not linear. All right, 7 and 8 want us to tell if it's discrete or continuous. Okay, so remember, discrete means it has the dots. Continuous means it has the lines. This one is a straight line, so this one is going to be continuous. And then it also wants us to find the domain. So not the range, just the domain. Remember, domain is my x's. So that's the furthest left point. Let's pick a color other than black. So my furthest left of the graph to the furthest right of the graph. The furthest left of the graph looks like it's going to be 1. Everything has to be greater than or equal to that. Remember, domain is represented by x. And it looks like it goes all the way to 5. And again, has to be less than or equal to that. It could be exactly 1. It could be exactly 5. We just write all the numbers in between. And then the last one here, it has these separate dots. So this is something that would be considered discrete. And then also with this, then remember when it's discrete, we have to just write out all the ones. So it looks like we have 1 at 1, 1 at 2, and 1 at 3. I don't see any more dots there. So it looks like our domain is just the 1, the 2, and the 3. Good luck.